State. You missed for state?
I do teach history.
You do. I love teaching.
The history of science.
I teach the history of science. I say, this dude from France did this thing.
I like hearing about that. I wish you could go into more into it.
Really? I do too, but there's been a push away from that stuff. Anything you look up on the internet, like who invented the capacitor, and you can look up that on the internet.
I know, but that's how I get up to 1 in the morning to start looking at TV.
Yep. Me too. I like you hang your hat on those little facts. You're like, oh, I remember that guy. Oh yeah, Boyle. Yes. Okay. Anyway, okay. So, ladies and gentlemen, if you're using a textbook, the next unit is chapter 13 and 14, solutions. This is a totally fun unit. There's some really cool labs in this unit. The one you're gonna enjoy the most is making soda pop, which right now is scheduled for end of next week or the following week. But you have to bring in the sugar and the flavorings. Okay, this is stuff that you can buy at a grocery store. You're gonna need a lot of sugar. You need to bring in the sugar and the flavorings. I'm gonna buy the dry ice and the bottled water from Costco. Well, bottled water from Costco. I'll bring the dry ice from Winco. So I'll bring the dry ice and the bottled water. You bring the sugar and the flavorings. Now, what I mean by flavorings, Kool-Aid powder, those little squishy bottles that you add to your bottled water so it doesn't taste like bottled water anymore. Italian soda syrups.
What?
Yeah. And it'll be just for this class. I'll have a bin where you can just store everything into your bin, and then on the day of the lab, we'll do the lab. Yeah. So again, probably gonna be middle to late next week. That's my hope. Okay. So some lingo about solutions. Lingo. Homogeneous. If you see a solution that has one phase, you can't tell where one thing stops and another thing starts, it's homogeneous or homogeneous. Literally means same stuff. Okay? Your apple juice this morning was homogeneous. You couldn't tell where the apple started and the sugar started. You could like, there's the sugar and there's the water and there's the apple juice and there's the vitamin C, there's that, and you couldn't see that. It was all one phase. If it's all one phase, we call it homogeneous. Now, if it's not homogeneous, it's heterogeneous. Heterogeneous literally means different stuff, different makeup. And a heterogeneous solution has obviously different phases. Your cereal had different phases. You're like, there's a Cheerio, and there's milk, and there's a Cheerio, and there's milk, and there's a Cheerio. Okay? That's a heterogeneous solution. So when you have like Italian salad dressing you have to shake up, or French salad dressing you have to shake up, you're like, there's the oil, there's the water. That's two phases. If it's two phases, you have a heterogeneous substance. This is all the math we're doing, right here. Molarity is the name we use for concentration. Now, I've used the term molarity before. I said this is a 1 molar solution. This is a 4 molar solution. This is a 6 molar solution. Molarity is amount of moles divided by the volume of the solution in liters. So moles over liters. So that's molarity. I'm going to draw it really big if you can't see in the back. Molarity is given the capital letter M. It's our concentration. And it is moles over liters. So molarity is moles over volume, if you will. That's molarity. Obviously, the more moles of something you have in the same volume, the more concentrated it is. Anything over 1 molar in this class, we're going to have to be wearing glasses because it could be dangerous. We used 4 molar when we did the penny. We used 1 molar when we did the H2 Pop Lab. A couple times, we've actually used 6 molar, which is by drops. So anything over 1 molar, it's concentrated enough to hurt us, so that's where we got to wear our goggles. Okay. Now, if molarity is moles over liters, and you take a molarity and you multiply it by a volume, molarity is moles over liters, and liters is, or volume is liters, what unit are you left with? Moles over liters times liters, you're left with what unit? Moles. Okay. Simple algebra, moles. So if you take a molarity, capital letter M, and you multiply it by a volume, you're going to get moles. Okay. Give me a thumbs up if that makes sense so far. Cool. And then this equation is the equation that we use if we want to dilute or concentrate something. If we want to make something more dilute or more concentrated, we say M1V1 equals M2V2. This is what I use to make the solutions for you. I don't give you the same concentrations I get from the chemical supply store. The chemical supplies that come in are usually 12 molar or 18 molar. They're nasty. I don't give them to you in lab because otherwise we'd all be choking on fumes. Like, 12 molar hydrochloric acid, I can't stay. You're like, I like chemistry. My nose is bleeding as you pass out. So I prepare the solutions in the back room with a fan going, so you don't have to suck on the same fumes that I have to suck on when I make the solutions. So you use lower concentration solutions that are safer. Yeah. I get the dangerous stuff. Yeah, I get nosebleeds for you. So we use M1V1 equals M2V2 if we want to concentrate something or dilute something. The important thing is if M times V is moles, what's the same on both sides of the equation? What's M times V? Moles. So there's the same number of moles on both sides. All you're doing is adding water. For instance, if you had some Kool-Aid and you're like, ooh, this Kool-Aid is too strong. What are you going to do? You're going to add water. Now, does the amount of sugar and Kool-Aid flavoring change? No. By adding water, you increase the volume, decrease the concentration, but the actual moles of sugar inside doesn't change. Does that idea make sense? Okay. So that's the heart of this equation. Okay, here's a joke. A brown bear and a white bear go for a swim, and the white bear dissolves. Why?
Or why? Why does the white bear swim?
Why does the white bear dissolve? What's a white bear? It's a polar bear. Remember how we talked about bonding? What is water? Polar. And water dissolves things that are also polar. So water dissolves polar bears. You were like, well, one has different colors and masses. Okay, 3 parts of a solution. A lot of this unit is lingo. So 3 parts of the solution. The thing that does the dissolving, the water in the Kool-Aid, is called the solvent. Fancy term for solvent is dissolving medium. Guys, stop yawning. Do you have a toddler keeping you up all night? I don't think so. Oh, somebody did. Okay. So the thing doing the dissolving is the dissolving medium. Medium is basically of stuff. Like the medium of your notes is paper and pen. Or iPad and electrons. The stuff that goes into the solvent is called the solute. Solute. That's the dissolved substance. And when you put the solvent and the solute together, you get the solution. Now the crazy thing about solvents and solutes is they can be any phase. I'm not wearing my wedding ring, but if I was, I would say, see my wedding ring? It's a solution of gold and silver. It's not pure gold, because pure gold makes lousy jewelry. Pure gold is just too soft and too dense. It'd be very heavy and it's very, very hard, or very, very hard, or very soft, so it wouldn't be all that useful. I'd get my ring squished all the time. So it's a mixture of 14 parts gold, 10 parts silver, or something else. So solutions and solvents, solutes and solvents can be any phase. The air that we're breathing right now is a solution of mostly nitrogen and some other oxygen and a few other things. So oxygen would be the solute, and nitrogen would be the solvent. See how that works? The gold would be the what? If it's 14 parts gold and 10 parts something else, the gold would be the what? Solvent, because there's more of it. And then the silver would be the solute. See how that works? Okay. Oh, were you done writing? Okay, electrolytes. This is fun. Electrolytes are solutions that conduct electricity. Rondo. Rondo's got what plants crave. Why are you laughing? You've never seen that movie. It's R-rated. You're not 18 years old.
You gotta be
17. I have my own.
17.
I go to the movies by myself.
That scene.
Saw Logan.
If you've never, oh, good for you. If you've never seen Idiocracy, I strongly recommend it. Yeah, well, Mr. P will not be able to show you that in video studies because it's R-rated. For too many references
He
to
actually
genitalia.
showed us R-rated movie from film too.
What? Exciting.
Yeah.
Okay, so a solution is, or an electrolyte is a solution that conducts electricity. Now I have here some water. Water. It's the same water I use to make solutions, same water I drink. It's right there. And I'm going to put them in a beaker. No, it's not. And no, I'm not. Tomorrow, you're going to investigate substances and whether or not they are electrolytes. I strongly recommend that you come in tomorrow with things to test. You can test bottled water, but if you have other things you want to test, like your sports drinks, test them. So this is one of those old-style light bulbs with a filament that goes through the middle. And this is a screwdriver made out of metal. When electricity is allowed to travel from one pole to the other pole, light comes on. Boop. Now this is the water. In both these beakers there's water. And I'm about to put the electrodes in the water. You're probably far back enough you don't need any goggles, so you're probably okay. What's going to happen when I put the electrodes in the water? Why do you say that?
Because you always see the people with toasters.
Yeah, there's signs on all your hair dryers that says don't use your hair dryer in the bath because if you drop your hair dryer in your bath, you'll all die. And don't put the toaster like the Groundhog Day. Don't put the toaster in the bathtub. Okay. Well, are you ready? Here's what happens when you put something that obviously has some pretty good voltage into water. Are you ready?
I got 911 on speed. Oh. Okay.
Oh.
I knew it was a church.
Okay. How come it's not turning on?
My whole electrolytes.
Because it's water.
Because there's no, not electrolytes, but there's no ions. Electrolytes are solutions that contain ions. The ions need to be there to transport the electricity, the electrons from one side of the pole to the other. Metal works pretty good because the electrons can jump from atom to atom to atom. But if you don't have metal, then you need ions.
So if you poke that with a shock.
If I use my finger, yeah, some electricity would travel through my finger. Oh, if I put my finger in there?
Yeah, well, that's it.
I'm not sure if I have the room. Let's see.
Oh my gosh.
It's fine. Okay. Yeah, it's fine. Now here's the reason that there's these signs on the hairdryer that says "Do not do hair drying when you are in a bathtub." You might notice all around you, your skin has tiny little pores. Yeah, they're all over you. And among other things that are ejected out of those pores is minerals, like salt. You think that you have to go to a spa to detoxify? No. All you have to do is pee, poop, or sweat. So, or just live. So you have a pretty good workout. Your body is covered in sweat, which has lots of salt in it. And then you jump in the bathtub, and you're like, I learned in chemistry that water is not a good electrolyte, so I'll be perfectly fine. I'm going to just make some toast while I'm here in the bathtub. And that happens. So what was the difference between before and after?
The light turned on.
Yes, the light turned on, but why?
Oh, sorry. You put ionic solution in the one.
Yeah, I put sodium chloride. Sodium chloride has ions, so the ions dissolve, and then we get an electrolyte. Now this is table sugar. Sugary. This is table sugar. I'm going to put table sugar in the other beaker, which was also water, and stir it up. No. I don't want to do that now. He said, put your finger in the water, the light now. Don't wanna.
Take it out and then.
Oh, like that? Well, that's fine. Okay, so here's my light and the electrolyte. Now I put sugar in this one. Now sugar also dissolves. The difference is there's no ions. So sugar is a covalent compound, and covalent compounds are non-electrolytes. They dissolve in water, but they don't have any ions. Yes?
How much does it take to make it actually conduct electricity?
Salt?
Yeah, how much would it?
Very, very little.
So it's like
So I can add some to my sugar solution. I'll just add like a pinch. That's like less than a pinch, but it does not take much. Oh, you can see it's glowing a little bit. A little bit more.
it's dimmer on.
It is dimmer. There's simply less particles. Now put them together. Oh, ah! Question? I don't want to put my finger in there when the light's on. You do that. Okay, so tomorrow you're going to use these things. These are conductivity testers that I made about 5 years ago when I came here to Boulder City. And they basically work like that big light, only they're smaller and safer. These you can stick to your tongue. Did it light up? Yeah. Anyway, this is just powered by a 9-volt battery, and there's 2 lights, and some of them have a buzzer inside too. So when electricity travels across, the lights turn on. They're yellow and blue because I made them for Boulder City. And you're gonna put some substances in a spot plate. Then you're gonna stick this in here and find out if it's an electrolyte. You're like, is it an electrolyte? Lights come on. It's an electrolyte. These are better than the ones I can buy in catalogs, and they're pretty fun to make. 1, 2, 3, 4. These are things you can make at home. 10. Okay, we have 10 of them. Cool. So that's a conductivity tester for tomorrow's lab. And they look like little capsules, like flying through space. Okay, questions about electrolytes? Moving right along then. Okay, so if something is soluble, we say it can be dissolved in water. If something is insoluble, we say it can't be dissolved in water. So soluble is able to be dissolved. Ionic solids are able to be dissolved because they disassociate into their ions. They disassociate into their ions. disassociate mean?
Let's take percent population, something else.
Yeah. If by you meant separate, that's exactly what it means. So when your mom says, he's a bad influence, you need to disassociate from him, it means you need to separate yourself from that person. Disassociate. Now I have an animation that you've actually seen before, but it's valuable, so I'm going to do it again. Why is it, or how is it, that water molecules cause solid ionic solids to disassociate? Anyone remember from back in November?
Is there something with like non-polar or like dipole?
That's exactly what it means. Yeah, and it has something to do with the dipoles. Remember, water has a strong positive and negative dipole. So those positive and negative dipoles tear the lattice apart. So you've seen this animation again, but it's so valuable, I'm going to show it again. You've seen this animation before. Here it is.
When an ionic substance, such as sodium chloride, is placed in water, water molecules interact with the ions on the surface. If the salt is soluble, the attractive interactions with water molecules overcome the ionic attractions within the lattice. The solvated ions move off the surface and become separated in solution. Notice that water molecules cluster about the anions with the hydrogens directed toward the negatively charged ion. On the other hand, water molecules interact with the positively charged cations through the lone pairs of electrons on the oxygens.
So water is polar. Polar things dissolve polar things. So since water is polar, it also dissolves polar covalent solids, like sugar. Sugar is a polar covalent solid, so it'll dissolve it. Now sugar won't make any ions, so it won't create an electrolyte, but it can be dissolved. So not everything that dissolves is an electrolyte. But everything that forms an electrolyte has to be able to be dissolved. So that just gives us, we learned about like dissolves like back in November when we did bonding. So polar things dissolve polar things, non-polar dissolves non-polar. We have fat-soluble vitamins that are non-polar-ish. We have non-fat soluble vitamins that are polar-ish. Okay. And again, I talked about this. Alloys are solutions of metals. Pretty cool. Okay, you probably don't need to write this down. It just means you can't see the ion. Duh. Now here's the crazy thing about solubility. Solubility depends upon temperature. Temperature changes how much stuff you can dissolve in a liquid, which hopefully makes sense. Because when you cause liquid molecules to warm up, what are they doing at the molecular level? Exactly, they're bouncing around, they're moving faster. So as they're moving faster, there's more gaps in between them. So you can stick more stuff. This is how they make Jolly Ranchers. What they do is they get a big pot of water and they put some sugar in it. Sugar, 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 until no more sugar can go in. Then what do they do to the pot of water? They warm it up. And they warm it up, and suddenly the sugar dissolves. And they're like, hey, let's put more sugar in there. So they put more sugar until no more sugar will go in, and it falls through. And they're like, let's warm it up some more. So they warm it up some more, and they throw more sugar in. And they keep doing that until they can't put any more sugar in. They put their flavoring and their sugar in, and they get like a paste. Then that paste has as much sugar as it can hold. Then what they do is they allow that paste to cool down. And they stretch it into columns, and they slice it into little pieces. And as it cools down, what does the sugar do? Yeah, it hardens. It comes out of the solution and hardens. That's how you make rock candy. Before you ask, no, we're not going to make rock candy in class. If you want to make rock candy, you can do that at home in 4th grade. But we're not going to do it in here. But you can go, if you want to make rock candy, just look online on YouTube, how to make rock candy, and then you can make rock candy. It's easier just to buy Jolly Ranchers, but that's how they do it. They completely warm up, add more sugar, add more sugar, add more sugar, add more sugar, keep adding sugar, and then when it gets to really, really warm, you can't add any more sugar, they let it cool down, and the sugar comes out. Here's the crazy thing about gases, though. Gases work exactly the opposite. If you take 2 cans of soda, one's in the fridge, one's on the countertop, so one's room temperature and one is 1 or 2 degrees, and you pop them, which one goes flat first?
One in the fridge.
Really?
Well, I think so.
Okay. The room temperature one should go flat first. And there's graphs for this. So when you increase the temperature of liquids, you can dissolve more solids but less gases.
Yeah.
The soda, the warm soda, has a lower solubility for gases. So the flatness is when there's no more carbon dioxide dissolved in the soda. So when it's warm, the solubility of the gas in the soda is less. So the gas escapes faster. So generally, for most things, when you increase the temperature, you can get more solids in solution, but less gases. What's another way that you can get lots of gases into solution? If I want to get some more carbon dioxide into solution, what's one way I can do that? Put it, yeah, we make it cold, good. You could also put it under pressure. Yeah. Henry's law states that the higher pressures, the more gas you can get into solution. So, more pressure you have, the more gas molecules you can squeeze into solution. That's Henry's law. Pretty simple. Anybody work or have worked in a restaurant that has a soda machine where you just push the thing and put soda down? Am I the only one? 1, 2, 3, a few of you? Okay, yeah. When I was 16 to 17, I worked burger joints. I flipped burgers, among other things. Flipped burgers, made fries, got grease oil burns. But if you've ever been in that environment, or maybe you've even heard it in the back, sometimes when you're getting the soda, it goes psh, psh, psh. You heard that? When you're getting your soda at Costco, it goes psh, psh, psh. Or In-N-Out Burger. So what's happening is in the back, there's a big steel tank of high-pressure carbon dioxide. And that psh noise is when the carbon dioxide is being added to the water. We're going to make soda. We're going to make soda pretty much the same way they make soda at In-N-Out Burger. How do they do it? Well, they do not buy Coca-Cola from the bottler. The bottler, somewhere, it might be here, might be in California or Arizona. The bottler sends them bags of Coca-Cola syrup, 3-gallon bags of Coca-Cola syrup, and they connect the syrup to the machine. Then they take water, and they make carbonated water. Carbonated water is just water with carbon dioxide added to it. The same water that comes out of the drinking fountains and goes into your toilet is the water that they use to make Coca-Cola. So they just add carbon dioxide to the water. That makes the water carbonated, makes it fizzy. Then they add a little they add a little bit of syrup to the carbonated water and it makes Coca-Cola. You've all seen it, where you're like, the big mystery of childhood is when you get your Coca-Cola, they love this, by the way. They make sure that it doesn't mix until the very last moment, because they love, like, it comes out clear, but then it ends up, Coca-Cola ends up brown in my cup. I love that. You've seen it, right? Where it comes out clear with a little line of, like, brown goo in the middle, and it ends up Coca-Cola in your cup. How does it do it? I have to buy more. It's amazing. Watch what they're doing. They're just taking the same water that they pump into the toilets. They're adding carbon dioxide and the little syrup, and that makes your Coca-Cola. Fun fact, your Coca-Cola tastes different in Nevada, southern Nevada, than it does in Colorado.
Better.
Different toilet water, exactly. The water is still coming from the Colorado Rockies, but the difference is in Nevada, that water's had 600 miles to pick up all sorts of minerals. Yeah. So, and those minerals end up in your Coca-Cola.
So we get extra nutrients.
You get extra nutrients when you drink your Coca-Cola.
I'm here
So
for
your Coca-Cola is basically a vitamin. It's basically a multivitamin.
Yeah.
There's so many minerals in it. And in case you think buying canned or bottled water or canned or bottled soda is that different, it's really not. There's not some like castle where they make all the Coca-Cola and they ship it to you. The Coca-Cola is just bottled downtown, you know, in the bottler. The same place they get the bags of syrup is where they just do the whole process before you and stick it in the bottle and hand it to you.
That's where those glass books are.
Yeah. Okay, some more lingo. If a solution has as much solute as it can hold, we call it saturated. If a solution has as much solute as it can hold, we call it saturated. When something is saturated and you add some more solute, the additional solute just falls right through, or appears to fall right through. We're going to do a simulation that actually shows what's really going on, so I'll leave that for the future. But if you have a saturated solution and you add more solute, the solute just sinks to the bottom. Sorry, there's no more room for me. I'm just going to go to the bottom and stay a solid solute. In reality, it's not falling through. It's dissolving and re-solidifying and dissolving and re-solidifying. Is that equilibrium we talked about last unit? An unsaturated solution is the solution that can hold more. It can hold more stuff. Would you rather drink a solution? Yes. Would you rather drink a solution of Kool-Aid that is saturated or unsaturated?
Saturated. Yes, I know it's
You would want to drink a solution of Kool-Aid that has as much sugar as it could possibly hold,
Yes.
even though it would be the consistency of syrup.
Yes. Have you ever had unsaturated? It's awful. With water.
Well, the Kool-Aid recipe calls for an unsaturated solution, where you add the flavoring and the sugar, but you can still add more. Saturated solutions of Kool-Aid, they taste like syrup, and they would be gross. Anyone ever have to drink that syrup because you had a diabetes test? Yeah, there's a test for diabetes where they make you drink a saturated solution of sugar, and it literally is nasty. It's like you have to gag it down. But it's sugar. But it's saturated. It's like syrup. Not good.
Wait.
Yes.
Would honey be saturated?
I don't know. Maybe. It's entirely possible honey is saturated. Somebody look that up. Is honey a saturated solution? We'll move on while you look that up. So I don't know if it is or not. We'll learn that out. Okay. So if something has more solute than it can hold, it's super saturated. If there's too much.
Hey, Jake, you
Yeah, it's a super saturated solution.
Honey is super saturated?
Yeah.
Yeah.
All right. There we go.
There's so much sugar.
Honey is super saturated. Look at me learning stuff with you. Yeah, that's science class for you.
I'm gonna do that when I get home.
Well, make sure you take a really good bath beforehand and clean all the skin, all the skin off you.
Yeah.
Just take a layer of skin off first, so there's no mineral sitting there in the pores of your skin. So make sure you take a full layer of skin off, then you can jump in the pool with the toaster, or jump in the bath with the toaster. Oh, and I also recommend you don't do it in Boulder City. Tomorrow, you're going to use lab water. You're going to use the lab water that we've tried to purify as much as we can, because Boulder City water. Oh, hey, look at that. We have good water today. But that's Boulder City water. At least it's not like, bah, but yeah, there are minerals in Boulder City water. Because again, it's been traveling through the Colorado River for a long time.
Wait, are minerals bad?
Are minerals bad?
Yeah, I
No.
thought they were good. So
They're good.
Are we like benefiting?
Yeah, some minerals are good. Some minerals are not.
That just means our livers.
Do you want to know?
Yeah, there's nothing wrong with the water you're drinking. It just doesn't taste good. I like my water to taste like nothing. Anyway, okay, so if we want to get things to dissolve faster, there's a few things we can do. What is one of the things we can do to cause solute and solvents to dissolve faster within each other? Heat it up. Good. We can heat something up. That causes the molecules to move faster. What's another one? Put it under pressure. Putting under pressure causes the molecules to get closer together. And what's the last one? It's called a mechanical device. Stirring it. Yeah, shaking it or stirring it. If we shake or stir, then we force the molecules to get closer together mechanically. Okay, questions so far? Almost done. Okay. Soda pop. Now, we're going to think about the CO2, the carbon dioxide in the soda pop. We're not going to worry about the sugar, which is a lot. We're going to worry about the CO2. Before you pop the tab, is the soda saturated, supersaturated, or unsaturated? Why don't you convince your neighbor? Take 30 seconds and convince your neighbor which it is.
I don't really know. I'm gonna get unsaturated.
Before you pop the top. It's in there.
No,
Before it goes. Okay, if you think the CO2 in the soda pop is unsaturated, raise your hand. All right. If it's saturated, raise your hand. If it's supersaturated, raise your hand. Yeah, it's supersaturated. And we know because that CO2 already has built up a pressure inside the can. There is too much pressure, there is too much CO2 in the can, it's supersaturated. Now when you pop the top and allow that extra pressure to go, then it's what? Then it's saturated. There's as much CO2 as it can hold at that temperature. And it warms up, or if you put other things in, like more water, other things, then it'll keep coming out. And if you shake the can, allow it to become flat, then it's what? It's unsaturated. There's still a little bit in there, but we can put more in. If you want to rephysify your soda, just drop some carbon dioxide in. Dry ice works pretty well. We're gonna put dry ice in water bottles, and the bubbling dry ice will cause it to become become fizzy. We are not gonna put the cap back on the bottles. We're not gonna make a dry ice bomb except as a class. We'll make one.
Yes, we're learning terrorism 101.
Okay, so we talked how soda was made. Okay, last thing. Suspensions. When we have mixtures of multiple phases, they can be a suspension, a solution, or a colloid. A suspension is a solution where the particles are so big, they settle out. This is a suspension. It's muddy river water. The laser just basically gets blocked. It doesn't come up out on the other side. It just gets blocked. And you can actually see down below the particles are starting to settle out. The mud, little bits of rock and sand are starting to settle out. That's a suspension. Misplaced my other green laser. Oh, there it is. So a suspension has particles that are very, very big, so they settle out, and we have multiple phases. These phases are very, very obvious. Muddy river water and Italian salad dressing are great examples of suspensions. Same thing? Fair enough. Chocolate milk is an excellent suspension, one of my favorites. Most of you know that if you leave chocolate milk alone for a long time, the chocolate will settle out. If you put it in a centrifuge, or it spins it around, the chocolate's going to settle out. And you can get rid of that useless milk and just take a spoon and do the chocolate on it. Okay. That's a suspension. Particles are very, very big. The next type of mixture is really wild. The next type of mixture has medium-sized particles. These particles are not big enough to settle out, but not small enough to totally dissolve. And we call that a colloid. Too fast? Okay, sorry. Well, you guys gotta be diligent about what you're writing down. Okay, that's a colloid. So a colloid has particles that are not small enough to completely dissolve, but too big, but are too small to settle out. And because colloids are so goofy, they get special names for their phases. Smoke is a colloid. The solid particles of soot, they don't settle out in the air, they stay in the air. Foam is a colloid. Shaving cream and whipped cream are colloids. Gels are colloids. Mayonnaise is a colloid. Mayonnaise is egg whites and oil that don't mix. But if you whip them together enough, they will stay as a gel gunk. Not a fan of mayonnaise. So they have two phases. The phase that gets dispersed, that is smaller, is called the dispersed phase. So again, the solute is the thing that is less, so we call that the dispersed phase. And the thing that is more is called the dispersing medium. There are 7 types of colloids. If you want to know what they are, you're welcome to look them up. They're in your textbook also. I do not care that you know what each type of colloid is. But basically it's liquid and solid, solid and liquid, liquid and air, gas and air, gas and gas, liquid and gas, solid and gas. You get the idea. Okay, 2 minutes. I have a bunch of stuff up here. This one is a suspension. The laser gets totally blocked. This one and this one both look fairly clear. Can you see the difference? Can you see the beam of light in the solution?
No.
Can you see the beam of light in the colloid? Yeah. In a colloid, the particles they're not dissolved, but they're still suspended. I realize it's kind of a weird word. The colloid, the particles are in there, so the laser can see them. This is a colloid too. Laser can see them. Laser can see them. This is just water. Okay. That crazy phenomenon where a laser can be seen in a colloid is called the Tyndall effect. I realize you can kind of see the laser in here. So it's the Tyndall effect. No light in laser, no light in water, light in water. Colloid, solution. Colloid, solution. It's a colloid. I can't see the laser. It's a solution. That's a Tyndall effect. And that's where we're going to end today. We got like at 90 seconds. I'm done. I'm done talking. Gotta learn how to be diligent about the notes you take. Because you're going to go to college and they're not going to be like, it's everybody.